Hi guys, Mr. Mustafa here. Welcome to part 2 of the video on solving June 2021 supplementary examination paper. Right, mathematics paper 2. I hope this exam paper helps you for your trial examination right on Monday. So let's see, analytical geometry, which is part 2 of 4. Part 1 of 4 was on statistics, where I solved question 1 and 2. Now we are in question 3 and we are doing analytical geometry. So let's go straight into the question. If you have not subscribed to my YouTube channel, please do subscribe and like and comment. Right, so question 3. In the diagram, S is the coordinate 0 and minus 16. S is the coordinate 0 and minus 16. That was given. L and Q are the vertices of triangle SLQ. SLQ. Right, perfect. We have 4 and minus 8. Having LQ perpendicular to SQ. LQ is perpendicular to SQ. Okay, we can see the 90 degrees. Everything is given. SL and SQ are produced to points R and M. So basically we have straight lines. SL and SQ are produced to R and M. Perfect. Alright, now respectively such that RM is parallel to LQ. RM is parallel to LQ. SM is produced, cuts the x-axis at N, which is 8 and 0. So basically we can kind of find the equation of this line, right? So in other words, if you find the gradient of this line, then you can find the gradient of this line because it's perpendicular, and you can even find the equation of this line, and there's so much of stuff we can do. And also these two lines are parallel. If you find the equation of this line or find the gradient of this line, then you can find the gradient of RM. Right, this is good. We're just not sure of one more thing. We can see parallel lines here. Maybe you can apply the midpoint theorem. If Q is the midpoint, if you can prove that Q is a midpoint of MS, then we can probably use the midpoint theorem, but we're not sure, right? So you can't really do that at the moment. You can just use similarity, SQ over red. Now let's see, QM is equal to MN, and T and P are the y-intercepts of RM and LQ respectively. T and P. Alright, so it's important to make sure that everything what you read here appears on the diagram and make conclusions about this. As I said, since this is perpendicular, remember you can find the gradient of this line, equation of this line, then you can find the gradient of this line and the equation of this line, because perpendicular lines, product of perpendicular, if the lines are perpendicular, the product of the gradients is equal to -1. If the lines are parallel, then the gradients are equal. So we have so much of information. Remember, you can also find the midpoint M using NQ, and we can even find the equation of this line provided we transfer the gradient from here to there. Right, so we kind of solve everything in this question. And let's look at the first question. Calculate the coordinates of M. To calculate the coordinates of M, as we said, is a midpoint, 3.1. M is a coordinate. 8 plus 4, which is 12, divided by 2, we will get 6. Right, and 0 minus 8 divided by 2. So we can do this, right? Add the two x values divided by 2. So 8 plus 4 divided by 2, and add the two y values divided by 2. 0 minus 8 divided by 2. So M is a midpoint, which is 6. Minus 8 divided by 2 is minus 4. 3.2. Calculate the gradient of NS. To calculate the gradient of NS, remember all these points lie on the same straight line. So if you can find the gradient of NS, you can either do change in y over change in x. You see change in y values is 16 and change in x value is 8, so the gradient is 2. Otherwise you can just find gradient of NS, M of NS, in other words gradient of NS, which is equal to y2 minus y1, so 0 minus 16 divided by 8 minus 0. So what we're getting is 16 over 8, which is equal to 2, or as we said, change in y over change in x. So the gradient is 2. 3.3, show that the equation of the line LQ, right? So obviously gradient of LQ is equal to negative a half because LQ is perpendicular to NS, right? Therefore y minus y1, or y is equal to mx plus c, so y minus y1 is equal to minus half into x minus x1 at 4 and minus 8, at 4 and minus 8. Right, so we substitute the minus 8 in the place of y, so y plus 8 is equal to minus half into x minus 4. Right, substituting into this equation, you can also take this point and substitute into y is equal to mx plus c, you get the same answer. It's just that you don't have to solve for c in this case, you just substitute this point inside here and you'll get the equation straight. In other words, we'll get y is equal to, remember the plus 8, we're taking it over, so we're getting minus half x, that's plus 2 minus 8, plus 2 minus 8 will give us minus 6, right? So minus half x minus 6, as we can see. Alright, so we have proved it. Now remember the coordinates of P is minus 6 there, we can write it down, 0 and minus 6, you can just as we go along we'll try to mark off the diagram, right? And then remember m we found, which is 6 and minus 4. This is helpful because now we can transfer the gradient from here to there. Parallel lines have equal gradients and we can use this point again to find the equation. Determine the equation of the circle having center O, right? So we're fitting a circle, equation of a circle having center O, right? Center O, the origin, and also passing through the point S, and is passing through the point S. So it's circle center O and passing through the point S. So you kind of have it's a really big circle, so I'm not really going to draw it. It's just that if the circle center is O and this is passing through the point S, right? So this is basically the circumference over here. That part over there becomes the radius. So the radius is equal to 16, right? So 3.4 x squared plus y squared is equal to r squared. In other words, x minus 0 all squared plus y minus 0 all squared is equal to r squared, and r was 16 squared. So x squared plus y squared is equal to 16 squared, which is equal to 256, is equal to, therefore x squared plus y squared is equal to 16 squared, which is 256. If you work out what is 16 squared, we should get 256, correct. Let's look at the next one. Calculate the coordinates of t. How can we calculate the coordinates of t? What's happening at t? Yes, t is the y-intercept. T is the y-intercept of Rm. So we need to get the equation of Rm, right? And then find the coordinates of t. So 3.5. Make some space here. Right, so I change my color a bit. Right, so 3.5. So looking at the equation of Rm, what's the gradient? Gradient is equal to the same as this gradient of LQ. Gradient of Rm is equal to gradient of LQ. So you can just say the gradient is equal to minus half, right? The gradient is equal to minus half because LQ is parallel to LM. So parallel lines have equal gradients. So LQ is parallel to RM, sorry, not LM, should be RM. Should be RM. Yes, should be RM. So now we have y minus y1 is equal to minus half into x minus x1 at the point that lies on M, which is 6 and minus 4. So at 6 and minus 4, minus 4 is a y value, so it becomes plus 4. Y plus 4 is equal to minus half into x minus 6. And if we solve for this, we should get y is equal to minus half x, we can see we're getting minus half times minus 6, which is 3, and 3 minus 4, which is equal to minus 1. So if we make x 0, then you can find the coordinates of t, which is minus 1. So 0, minus 1. Therefore, the coordinates of t is 0 and minus 1. I think that's what they wanted. They wanted, was that a t? Yes, the coordinates of t is 0, minus 1. All sorted. Let's look at the next one. Determine LS over RS. So we want to find LS over RS. What is LS over RS? So LS over RS, right, that's what we want to find. So we can clearly see that we have LS over RS. I did mention this earlier. We can use proportion. Right, so LS over RS, let's see, ratio and proportion. .6, you can say LS over RS is equal to, just open another. Alright, so what we're saying, LS over RS is equal to QS. LS over RS is equal to QS over MS is equal to QS over MS. QS over MS, and that is prop theorem. Right, why is it prop theorem? Proportionality theorem, and we can write down LQ is parallel to RM. LQ parallel to RM. LQ is parallel to RM. Okay, now we need to find what's the distance QS and MS. So we can say QS is equal to, use the distance formula for QS. QS and MS. How many marks is that? 3 marks. QS over MS. I hope it simplifies easily. Let's see. So QS is equal to, let's see, QS. Okay, let's write down all the coordinates. M, S, and Q. Yeah, so Q is 4n minus 8. So Q is 4n minus 8. Right? And then S is 0, 16. 0 and minus 16. And M was 6 and, yeah, we did solve for M. What was M? M was 6 and minus 4. 6 and minus 4. So we're looking for QS. QS is the square root of, QS is the square root of, distance formula, QS, square root of minus 16 plus 8, minus 16 plus 8, okay, let's use x2 minus x1. So 4 minus 0 all squared, 4 minus 0 all squared plus 4 minus 0 all squared minus 8 plus 16, minus 8 plus 16 all squared. Because why plus 16? Because minus 16 when you're substituting into the formula. Right, so let's shift this aside. Right, and we're going to enter this on the calculator and just get the solution for that. So that is QS, which is equal to let's see, square root of 4 squared, I'm not going to say 4 minus 0, plus, right, and then we got minus 8 plus 16, which is just 8 squared. That's going to give us 4 root 5, 4 root 5. And if you say MS, that is square root of MS, so 6 minus 0 all squared plus minus 4 plus 16 all squared. and that should give us square root of 6 squared. 6 squared, let's take this out, 6 squared plus 12 squared should give us 6 root 5. Right, so lovely. Therefore, this implies QS LS over RS is now equal to 4 root 5 over 6 root 5, which is 2:3, because the square root of 5's cancel out and then 2 can go into both 2 times, so 2/3. That's your answer. Right, good question. Lovely. And then calculate the area of triangle PTMQ. Area of triangle PTM, area of triangle calculate the area of PTMQ. PTMQ. Okay, so what we can see here is PTMQ. This is the trapezium, right? Right, so that is the trapezium. Okay, let me explain this using, right, so PTMQ. So basically this is a trapezium because we have one pair of parallel sides, one pair of parallel sides, right? So this is a trapezium. And how do you find the area of, now remember we found MS and QS. We found MS, QS, so we can find MQ. This is important because we need the perpendicular height. So half sum of parallel sides. So what's area of trapezium? Easy peasy formula. Area of trapezium, you can do 3.7, right? So you can look at 3.7. Area of trapezium is half sum of parallel sides times perpendicular height. Now let's see. The sum of parallel sides will be PQ and TM. It will be PQ and TM. So in other words, we need to find PQ and TM. PQ and TM, and the perpendicular height is in between here, we can see, which is MQ, but we don't need to go and solve for MQ because we had, remember, right? So need some space, right? Let's see. So MQ is equal to, let's write down MQ, which is the perpendicular height. MQ is equal to MS minus QS. Let's write down. MQ is perpendicular height, which is MS minus QS. MS was, we found MS 6 root 5 minus 4 root 5. QS is 4 root 5. So that will give us 2 root 5 like terms. Then what is sum of parallel sides? So sum of parallel sides, you can look at the first side, which is PQ. So what's the distance PQ? Can we find the distance PQ? If you got QS, oh yes, we can just use Pythagoras, or we can use the distance formula, right? So let's just use the distance formula for PQ because we have the coordinates of P. Yes, what is PQ? So you can say PQ is equal to square root of, I'll write the two coordinates down. So P is P was minus 6, so 0 minus 6, right? And Q was, let's look at it, the diagram, 4 and minus 8. 4 and minus 8. So we can find the distance PQ using distance formula. So 0 minus 4, or let's do it like this, 4 minus 0 all squared plus minus 8 minus 6, so minus 8 plus 6 all squared. So if you enter that on the calculator, right, obviously it's easy for me to work out, but just to be safe, you want to use a calculator, right? So you say square root of 4 squared. I can see that minus 8 plus 6 is minus 2, so I'll say plus minus 2 all squared. If you want, you can just enter it as it is, you get the same answer, 2 root 5. So we got 2 root 5. That's one parallel side, and the other parallel side we need to calculate is, that's 2 root 5. Okay, is Tm, right? So what's the coordinates of T? The coordinates of T, I think it was 0 and minus 1. Coordinates of T, let's see, 0 and minus 1, and M is 6 and minus 4, and M is 6 and minus 4, right? So Tm is equal to the square root of, let's see, 0 minus 6 all squared plus minus 1 plus 4. Minus 1 minus minus 4 is plus 4 all squared, and you can write that answer down, which is minus 6 all squared. So again, square root of, delete, open bracket, 0 minus 6 is minus 6 all squared plus minus 1 plus 4 is 3, so just 3 squared. If I have a minus, then make sure put a bracket around it. So we got 3 root 5. So lovely. So area is now equal to, area of the trapezium is half sum of parallel sides is 2 root 5 plus 3 root 5 times the perpendicular height, which is 2 root 5, and guess what answer we get? We get half 2 root 5 plus 3 root 5 is 5 root 5 times 2 root 5. We can clearly see that there's some stuff that's cancelling out. We just cancel them out, right? So you can see the 2 and the half cancel out, and we just left with 5 times root 5, 5 times 1, which is 5, and then root 5 times root 5, which is 5, which is equal to 25 units squared. And that's perfect. That completes this question, which is question number 3 for 19 marks. Right, let's move on to question number 4 of analytical geometry. Right, so in question number 4, what do we have here? We have a circle geometry. Let's just open the PDF as well and see. So we're dealing with this question over here, right? So okay, I think it's better here. So okay, let's read here. In the diagram, P is minus 3, so we can mark off. That's the reason why I'm opening this one. In the diagram, we have the point P, which is minus 3 and 4, is the center of the circle. V, which is K1, and W are endpoints of a diameter. So this is the diameter. In other words, endpoint of the diameter, that point is V, which is K1, right? That point there. Now, and W are the endpoints of a diameter. W, VK1 and W. Oh yeah, that's the other point. In other words, it touches the circumference of the circle. The circle intersects the y-axis at B. You can see the right point of intersection of the circle is at B and C. Yeah, B and C. BCVW, yes, is a cyclic quadrilateral. Now, very important, the properties of a cyclic quadrilateral, that opposite angles are supplementary, right? So CV is produced to intersect x-axis at T. OTC is alpha. Angle OTC is alpha. Now, from this, what can we extract? So we have the center of the circle, and can we get the radius? Well, we need more information, right? We couldn't fill in much information here. That's all as it is. Now, the radius of the circle is square root of 10. Perfect. So this is very helpful because the radius is square root of 10. Then we can find the value of, then we can find the value of k. Of course we can find the value of k, because if you say the radius is root 10, it means 4.1. It means that PV is equal to square root of 10, right? Which is radius, right? So PV is the radius. Remember, PV is equal to PV. Yes, so if you can get the value for k, then we can find the value for W, because these are midpoints. PV is equal to square root of 10. So now the coordinates of P is -3 and 4, and the coordinates of V is k and 1. Let's solve. So PV is the square root of, right? Square root of. Let's just shift it a little bit more towards this side. Right, so we can say PV is the square root of this one here. So k plus 3 all squared plus, so you got k plus 3, k minus 3 is k plus 3 all squared, plus 1 minus 4, 1 minus 4 all squared. So x2 minus x1 all squared plus y2 minus is equal to square root of 10. We can square both sides, so the square root falls off. So we got k plus 3 all squared is now equal to 10. If we square this, we're getting 9. So take it over, becomes -9. We don't have to go and open up this entire bracket here. All we can say is k plus 3 is equal to 1. If we square root both sides, we have to say plus minus. Therefore, k plus 3 is equal to plus or minus 1. We're going to get two answers. So we can say k is equal to -1 minus 3, or k is equal to plus 1 minus 3. So we are getting two values for k. Plus 1 minus 3. Therefore, k is equal to -4, or k is equal to -2. So which value of k should we take? Okay, so the value of k that you should take is, see, look at this coordinates of p here. This coordinate of p is -3. So the value of k that you should take is -2, because -2 and then -3. You have to look at the coordinates. So not applicable here. So there is only one value of k, which is equal to -2. Let's just double check our calculation. P was the coordinate -3 and 4. V is k and 1. So we said k minus k plus 3 all squared is equal to 1 minus 4 all squared is equal to square root of 10. That is PV, right? Then we're squaring both sides. Then we kind of have a plus 9 here. Yeah, if you have a plus 9 here, then let's just take this out here. So 10 minus 9 is 1. We have this equation. Then square root both sides. We have plus minus 1 on this side. So k is equal to -1 minus 3, or k is equal to plus 1 minus 3. So we're subtracting -3 on both sides, which is correct. So -2 here and -4. So there is only one value of k, which is -2. Right, so provided the radius of the circle is square root of 10. Or you could have substituted the point V, which is k1, in the equation of the circle, where the equation of the circle is x plus 3 all squared plus y minus 4 all squared is equal to 10, and you can substitute the point k1 and get the value for k. Same thing. Next one. So calculate the value of k if point V is to the right of point P. So we did the right thing over here. Right, so I didn't need that information because we can clearly see on the diagram. The equation of the circle is given in the form x squared plus 6x plus y squared minus 8y plus 15 is equal to 0. Calculate the length of BC. Calculate the length of BC. So in other words, the equation of the circle is already given. To find the length of BC, those are the y-intercepts. So you need to make x 0. So 4.2 let's make x 0 in this equation. So if x is equal to 0, we have y squared minus 8y plus 15 is equal to 0. So if we factorize, we can get y and y, which is equal to 0. We can use 5 and 3. So minus 5 minus 3. Therefore, y is equal to 3 or y is equal to 5. So we can fill in information here. Very nice information. There's 5 there and there's a 3 there. So what is the distance BC? It's just a vertical distance. It's just a drop from 5 to 3. So distance BC, therefore BC is just equal to 2 units. Okay, so the distance BC is 2 units. That's sorted out. Next one. If k is equal to minus 2, right, so these are some of the hints that they give you. Obviously, if you couldn't solve it here, then take it here. Right, so if k is equal to minus 2, calculate the size of alpha. So why did they give us that? Right, so if k is equal to minus 2, you should calculate the size of alpha. Now you can see the point, if you, in order to calculate alpha, is along this line over here, right, along the line TC, is making an angle of inclination. So tan theta is equal to gradient, so 4.3.1, right, 4.3.1, we can say tan. Let's calculate the gradient, right? So remember, we are using tan alpha is equal to gradient of TC, right? And the gradient of TC is, what is T? T is a coordinate. We just found the coordinate T. No, we can't find the coordinate T. Gradient of TC is the same thing as saying gradient of VC, because points are collinear, lies on the same line. So you can just say gradient of VC. Right, so V is minus 2 and 1, and C is 0 and minus 3, 0 and 3, not minus 3, should be 0 and 3. Now if we solve the gradient, it is 1 minus 3, y2 minus y1 over minus 2 minus 0. So we're getting minus 3, 1 minus 3 is minus 2 over minus 2, which is 1. So the gradient is 1. I could have also the change in y over change in x. Let me just check that. Change in y over change in x. So yes, we are getting the gradient 1. And that's no problem. That is sorted out. Since the gradient 1, we can say tan of alpha. Let's make some space here. Right, so what we can say now is tan of alpha what we can say now is tan alpha is equal to 1. This implies alpha is equal to tan inverse 1, right? You can use a calculator or think of it as special angle. Alpha is equal to 45 degrees. Tan of 45 is 1. So we have solved for alpha. Right, so this is alpha, which is 45 degrees. Perfect. Now the next one is VWB. How are you going to find the angle VWB? VWB. VWB. In other words, we want to go and find that angle over there. Yes. How can we go and find that angle? VWB. There's just 2 marks. How can you go and find the angle VWB? So what we can do here is, let's see, it's just 2 marks. Right, so what we can do here is look at this triangle CTO. So we got 45 degrees here. Then this angle over here, look at this triangle here. So let me just highlight it. So this triangle over here, look at this angle over here. This angle over here is an exterior angle of triangle TOC. So we can calculate angle VCB. So let's write angle VCB. Angle VCB is equal to, I just pop up this, so VCB, that's 45 degrees. So looking at the triangle TOC, so yes, VCB is equal to 90 plus 45, and the question number is 4.3.2. which is 135 degrees exterior angles of triangle. It's good to write reasons. Exterior angles of triangle TOC. Therefore, what is angle W there? What is angle W over here? This angle W over here is opposite angles of cyclic quad, because they're telling us VWBC is a cyclic quadrilateral. So opposite angles are supplementary. So angle W, so what did they want? Let's see, VWB. So VWB is equal to 180 minus 135, should give us 45 degrees. Opposite angles of cyclic quad, right? Should be a reason. Opposite angles of cyclic quad. Just erase this off. A highlighter here, so separate. Opposite angles of cyclic quad. What's a cyclic quad? They told us BCVW. BCVW. Right, lovely. That's sorted out. A new circle is obtained when the given circle is reflected above the line y is equal to 1. Okay, so I just want to copy this question and come back to you now. So welcome back, guys. I didn't want to waste your time, so I just recopied this question because I wanted to explain it to you. Now we want to calculate the coordinates of Q, the center of the new circle. Right, so a new circle is obtained when the given circle is reflected above the line y is equal to 1. So reflecting this circle above the line y is equal to 1. So where's this point y is equal to 1? Let's see. So we can see this point over here is y is equal to 1 is right here. Right, so we're continuing from here to there. Right, so the line y is equal to 1. If you're looking at the x-axis, that's a line y is equal to 0. Okay, now you are reflecting this line, you're reflecting this point, so we're trying to find this point P, which is the center of the new circle. This point is, yeah. So you're kind of reflecting this point on this line here as well. Every point is reflected on this line. So this point over here is reflected on y is equal to 1. Then this point should become, let's see, what's the distance in y values from here to this line? So if I observe the distance in y values from here to the line, I'm seeing a distance of 3. Remember, if I reflect this point on this line, then obviously the center will be somewhere around here, but 1 second. Yeah, the center should be somewhere around here, down, where the x value remains the same, so minus 3. So the coordinates of Q is definitely minus 3, so 4.4.1, that's what we're doing here, right? I'm just doing it on the circle, 4.4. So Q is minus 3. Problem is with the Y, right? So the distance between the line Y is equal to 1 and the Y value here is 3. So the distance between these two should also be 3. Yeah, exactly. The distance between here and there should be 3. So this point becomes minus 2. So yes, and that distance is also 3 from Y is equal to 1 to, yes, if I take the distance from the x-axis, is this correct? Minus 3 and minus 2. Minus 3 and minus 2. What if I take, let me look at this now. If I have this point which is C, which was 3, and the point was 5. So distance between those two, so that point goes to minus 1, and that should go to minus 3. The coordinates of B, in other words, B prime, the reflected point B will become minus 3. And you could have seen over here that the center of the circle is midpoint between 5 and 3, which is 4, Y value 4, and midpoint between these two, which is, yeah, so Q should be minus 3 and minus 2. So 4.4.1, coordinates of Q is minus 3 and minus 2, sorted. So the equation of the new circle in the form x minus y. So what's the equation of the new circle? X plus 3 all squared plus y plus 2 all squared is equal to r squared. Remember, r was square root of 10. Same as before. Let's just double check. R was square root of 10. R is equal to the square root of 10, which is, and we're saying r squared here, so should just be 10. So x plus 3 all squared plus y plus 2 all squared is equal to 10. Then 4.4.2 and 4.4.3. Yeah, these questions are level 4, guys, very difficult. Alright, let's see, question 4.4.3. Equation of the lines drawn parallel to the y-axis and passing through the points of intersection of the two circles. So where are the two circles intersecting? Points of intersection of the two circles. If you were reflecting it on, let's try and substitute y is equal to 1 inside the original circle and see what we get. If you substitute y is equal to 1 in the original circle equation, because I needed these points. If I have y is equal to 1 in the original circle equation, then what's the original circle equation? X plus 3 y minus 4, x plus 3 y minus 4. I have x plus 3 plus y minus 4 all squared is equal to 10. At y is equal to 1, we need x values. I need to know what the x values are at y is equal to 1. Do we have those x values when y is equal to 1? Yes, we did have the x values. This was minus 4 and this was, yeah, because when we saw for k, we said k is k and 1. So if we do try to solve this, we are going to have x plus 3 all squared plus 1 minus 4, which is 9, is equal to 10. So we kind of solved this. So x is equal to, yeah, so this is already solved, so we don't need this. Just x is equal to minus 4, x is equal to, instead we had a k there, x is equal to minus 2. So those are the vertical lines where it's intersecting at y is equal to 1. So minus 4 and minus 1 here. And the equation of the lines drawn parallel to the x-y axis and passing through the points of intersection of the two circles. So points of intersection of the two circles will be at -1 and -4 if you're reflecting it over the y-axis. Yes, should be at -1 and -4. So we're trying to find, so these lines are parallel to the y-axis, therefore, yeah, those will be the two solutions. Those will be the equations of parallel lines. Just want to check if you get the exact same answer if you substitute y is equal to 1 in here. Yes, we do get the exact same answer if we substitute y is equal to 1 inside this equation also, because we're going to get x plus 3 all squared plus 9 is equal to 10. Perfect. So we do end up, so looks right. It's right. I hope you guys enjoyed this video. Please look for the description. Right, in the description you'll find video links to part 1, part 2, part 3 and part 4. Right, so my next part of this video will be on trigonometry, and then I will do Euclidean geometry, which is last. So remember guys, maths paper 2 is broken up into 4 different sections. Right, so first one is obviously statistics. As you look at this paper, in stats, how many marks we had? In stats there was 14 and 9, yeah, about 23 marks in stats. Then we're looking at 19 marks in analytical geometry, 19, and look at this 20, which is approximately 30 marks in analytical geometry. And our trig is a big one, which is approximately 18 marks and 13 marks. 18, 13, that's 31 and 9, approximately 40 marks of trig. Okay, so don't miss out my video on trigonometry. Thank you.